Hey everyone, welcome to week 9, audio coding with SuperCollider. So this week we're going to be talking about GUI, or graphical user interfaces. We don't need to boot the server right away. I'm going to do it anyway. Just make sure we're live here. Hey Riantel. Okay, so we're going to be talking about GUIs, which is graphical user interfaces, or designing visual elements, windows, buttons, knobs, faders, all sorts of things. So this is all possible in SuperCollider. And morning, Cody. We might find ourselves in SuperCollider. I frequently find myself just kind of doing everything with code and not designing an interface. But it's nice to have a visual representation of what's going on in the code. It's good practice, I guess. It's useful in some situations, and especially if you're like sending your code somewhere else. It's a lot nicer to present somebody with a clean labeled window with a sort of easy to use interface rather than just a bunch of code. So a couple of helpful files worth checking out. There is, well, let's go browse. Let's go GUI. And there is these two here are pretty useful. Introduction to GUI and list of GUI classes. So intro to GUI kind of just walks you through. We've got the window, which is our sort of, it's the way we actually create a GUI window, and then we put objects that are called views on it. And then a couple of little code examples that walk you through this stuff. So this is a pretty decent tutorial, worth a read. And there's also list of GUI classes. And I'm going to scroll. I'm actually going to make some space here and detach this. So I'm going to skip past this kit independent GUI classes here. And we're going to go to window and views. And so the left column here, these are the actual class names that we end up using. So just window, capital W. We have things like button, pop-up menu, slider, range slider, slider 2D, text field, etc., etc., etc. At one point in the past, I think fairly recently, there was a redirect system in place. So you would have one of several GUI kits running on your computer, and you might be using Mac or Windows or Linux. So there's Cocoa GUI, Swing GUI, Qt GUI. And the idea was that you use these classes here, and then SuperCollider detects which GUI kit you're using, which operating system you're using, and it will pick the appropriate corresponding item. And according to the GUI help file, I was just reading this morning, the redirect system has been deprecated. So we still use the leftmost column names here, but according to this file anyway, Qt runs well on all platforms. So I think things like window now always directs to Q window. Anyway, this is a bunch of mumbo jumbo we don't really need to worry too much about. Let's just see it in practice. So we are going to make a new window. Right, so this is basically the simplest possible thing we can do. There we go. We made a window. Where is it? It's nowhere to be found. The reason we don't see it is because windows are not visible by default. So if we say w.visible, that's not visible. Visible returns false. So we can say true. And this will make our window visible. It should anyway. Let's see. Oh, I think, no, this is not, no, I'm mixing it up with something else. We want to call front on the window. And there it is. Yeah, visible I think is something that maybe it applies to Windows, but that's we can just call w.front, and I think this has the effect of making it visible and also making it the topmost thing. We don't have to put these in separate separate lines of code. Let's say w.close, get rid of that window. This is the same as just clicking the close button on the window. So we can chain methods together. We can say window.new.front. And so here we make a window, pops up, there it is. We can close it using this button or by saying w.close. So let's go into the actual new method here. We're going to put this on a separate line. We're going to take a look at some of the things we can specify about a window when we create it. So we have name, bounds, a boolean as to whether it's resizable, a boolean whether the window has a border, and then server, which I don't know, is that even still used? Let's see, window. This is a dummy argument, which is here to provide compatibility with Swing OSC and has no effect. Okay, and then this is whether you can, I think whether the window will add scroll bars if you put things on the window that are out of bounds. All right, so I think it's just easier to just do these one by one. So when we do this, we just have a window. It's kind of completely empty. It's a pure vanilla template of a window. So the first thing we can provide for new is a string, which is the name. Call this my window. And so now it's got a title, my window. So you can title your window, just like there's a title for this window up here, untitled, SuperCollider IDE. All right, and next is bounds. Bounds expects an instance of a class called rect, which is an abstract representation of a rectangle shape. And rect.new takes 4 numerical values, left, top, width, height. So let's say, so this is sort of, now for window, I think it counts pixels from the left side of the screen and then pixels up from the bottom of the screen. For the lower left-hand corner, let's see if I've got this correct. And then width and height is the width and height in pixels. So let's say 300, comma 300, and then 500, comma 500. Okay, so what I think it did, if you can see on the stream here, it's the bottom left corner is 300 pixels from the left and 300 pixels from the bottom of my screen, and then the width is 500 and the height is 500. It's the this square area right here. Now if we run this again, let's change this. Let's make it 600 over from the left, 200 up, and let's make it 400 long and 200 tall. Right. So now we got a different window over here. So if you're following along, you should be hopefully seeing something similar. If you're just writing along with this code, you should see little windows popping up. So now it's 600 from the left, 200 from the bottom, and 400 wide, 200 tall. Pretty easy. So that is rect. You can look at the help file for rect. There's some alternate ways of specifying rectangular shapes. I've just gotten in the habit of using this method, just saying from the left, from the bottom, width and height. And we've done something silly here, and we've called both of these windows W. So if we say w.close, it closes the more recent window. This one's also called W, but we overwrote it with a new window. So all we can do now is close it like that. But if we do, let's go random value between 300, 600, and a random value between 200 and 500. And let's make this a little square window. And we'll just do this a couple times. Right. And now we have a big cluster of windows here. And if you ever find yourself in this situation and you don't feel like clicking on all these things, you can do window, the class. There's a class method, window.closeAll. And this is nice because it just gets rid of all that. If you do have things like your scope open or your meters open, window.closeAll will also close these. So it's just good to manage your windows. And one thing I've gotten in the habit of doing is saying w.close at the very top of my code here. So And it doesn't really matter that, W may or may not exist. Like if we say x.close, yeah, we get an error message, but, big deal. We'll just ignore that. So now we can say, we sort of close the window if it's open, and then make a new window. And we're working with it, and maybe we're saying, okay, I want this window to be a little bit larger. So let's fix these values at 500. 500 in and up from the lower left corner, and let's make it 500 by 500. There. So now it closed the previous window and made this one. You can shift it over even more, and make it a little smaller. Yeah, okay. All right, so that's rect. It's not just applicable to Windows, but as we get into other things like sliders and buttons and things, rect is really a crucial part of building and manipulating GUIs, because every GUI object, a window itself and the objects on the window, all have an inherent rectangular space that they occupy, and we can specify and manipulate that by using the rect class. Okay, so we got a window. What else do we have? If we say resizable false, then we cannot resize the window, try as hard as we like. If we make this true, then we do have the ability to change the size. Again, this is kind of like, the developer's perspective for the user. It's like, do I want my user to be able to mess with my window and change its size? Yes or no? Different circumstances. And then there's also whether it's got a border, and that's true by default. If we say false, then it is just a pure, it's just the sort of the business part of the window. It doesn't have the title bar, doesn't have the close window. We can't move it. It's just kind of this awkward shape now, kind of obscuring things. We can't move it around. So the only option at this point is to say close, and then it goes away. Okay, so let's put some objects on the window. Let's just forget about these. And so we've got, we're sort of doing our cleanup. We create our window, and then we say bring it to the front. So usually, let's copy this and paste it. So we're down a little bit more, save that. All right, so we want to create the window and then put stuff on the window. And then the last thing we'll do is we'll bring it to the front and make it visible. So let's take a look at, we can go to this introduction to GUI, I think. Is this the one? No, it was a list of GUI objects. List of GUI classes. So let's take a look at slider. So we'll say tilde sl equals slider.new. Slider needs two things. At minimum, it needs to know what is my parent view. So all views have a parent. It's the view on which they are placed, and they have again bounds. So that's going to be rect. So we'll say the parent is W. That's our parent view, our window, and we were going to say rect. Let's say we want this to be, and here's it gets a little bit different here with Windows. Our first two coordinates are from the lower left corner, sort of away from the left and away from the bottom. With putting views on a GUI window, it's from the top left, I believe. So we'll go 50 pixels in, 100 pixels down, and we'll make this 30 pixels wide and 150 pixels tall. And let's just stop right there. All right, so yeah, 50 pixels in, 100 pixels down. Let's just confirm. So let's make this 20 pixels down. Yeah, so it's the first two numbers are counting in from the left corner, down from the top of the window, and then the size. So 30 wide and 150 tall. And it's a slider. So it moves, it doesn't do anything, but it's there, and we can move it. So let's make it do something. Let's make it post its value. So with a slider, there's some inherent value, like it's at the bottom, it's at the top. So the way we can do that is we can say tilde sl.action. Sorry, I didn't mean to evaluate that. And underscore, and then in parentheses, a function which represents the code, the action to be taken whenever the slider is interacted with. So we can say hi.postLN. And what did I do? Okay, I forgot a semicolon right here. All right, so now if we move the slider, every time it's interacted with, I'm going to clear the post window. Clear the post window. Yep, so we just click, 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 and drag. And we just, every time we interact with the slider, it's evaluating its action. So we kind of did something similar with MIDI def, where we just ignored all of the MIDI data coming in, and we instead just said, just print a string. And that's not really useful. It's kind of interesting, but whatever. So we can say arg view or anything. It's this, we can call this anything we want. It's kind of like when we do or collect, we can declare 2 arguments, and that's going to represent the item in the collection and the item's index. And with a MIDI def, we can say value, controller number, channel, whatever. So in an action function, we declare 1 argument, and it represents the instance of the view object. In this case, it's a slider. So we can say view.postLN, and this is going to not quite do something totally useful here. It's just posting itself. I'm a slider. That's what I am. We don't want that. We want the value of the slider. So we move it up, move it down, and you'll find that all views that have an inherent numerical value are by default normalized to a scale between 0 at the minimum and 1 at the top. So other ways we can interact with views. SL, let's say dot. We gave this a tilde name, which is sort of nice because now we can interact with it in a separate code context here, in a separate scope. So we can say, let's see, sl.visible. That is true, and we can set it to false, like this, and it's gone. It's still there. It still exists. I think we can still query its value. Happens to be 0. So if we move it here and hide it again, it's still got its value. There are situations where in designing a GUI, you want to make things invisible so that they don't distract the user, or for some reason you don't want them to be editable for that particular moment. So this is how you do it. If you go to the view, let's go to the view help file. So view is the abstract parent class of all usable GUI objects. So like knobs, sliders, buttons, etc. It's kind of like how node is the abstract superclass of synth and group. We use synth and group. We never actually use node directly. It's there to define the behaviors and attributes of the actual children classes, synth and group. View is kind of like the same thing. It's we very rarely will talk to the view class directly, but instead it provides this large list of instance methods that all views understand. So sliders, knobs, 2-dimensional sliders, range slide, everything understands all of these messages. We can say, what's your parent view? What are your children views? Remove, this is like just a sort of permanent deletion. Let's see, whether it's visible, here's the one we just did. You can ask for the bounds or set the bounds. So basically you can move it around. Appearance is a pretty useful thing. That's down here, I think. Yeah. So you can say the transparency of the view. 0 is invisible and 1 is fully opaque. If it's got text involved, you can set the font. Background color, let's go ahead and do that. So we'll say true, and let's say sl.background. Color. So an instance of we haven't seen the color class yet. This is a class which represents a color value. By default, it's got 4 values: an RGB, a float between 0 and 1, and then a transparency value called alpha. So let's say 1 1, 0, 0. We're going to ignore alpha, which is by default fully opaque. So we've set the background to be red. Now it's green. This makes it cyan. Got the combination of green and blue. And we can do half colors, fractional values here. There is color.rand. Just pick a random color. There's also a few convenience methods, color.red, yellow, magenta. So yeah, check out the color help file, and this is all pretty basic stuff. Note that we can also set the color of the background of the window, like this. Right. And then we can say, I'll tell you what, let's do point2.wait loop fork. And okay. Yeah, so what I'm trying to do is just make this sort of flash random colors. And this is an error that you will inevitably come across when dealing with GUIs. Error Qt, you cannot use this Qt functionality in the current thread. Try scheduling on app clock instead. Okay, so when we fork a function, it plays on a clock. It gets scheduled on one of 3 clocks that exist. There's system clock, there is tempo clock, and there is app clock. I believe a routine that gets played, or a function that gets forked, gets played on tempo clock. So it's there's some default tempo clock, I'm pretty sure. And the only clock that is able to schedule calls that interact with GUI elements is app clock. So I think we can say, yeah, the first argument to fork is a clock. So we can say app clock, and now this should work. Yeah, so flashy, very nice. Very, very pointless. Right? You can do this with your GUIs if you really want. All right, so we stop that routine. Another way that you can, if you're forking some function, that's if you're using fork or playing a routine explicitly, I think this is a good way to do it. Is just say, okay, we're gonna create a little function here, and we're gonna play it on the app clock. Right. Okay, I don't want to get too sidetracked here, so let's have some space here, and let's come back to this. One syntactical thing I've gotten in the habit of doing is not putting sort of separate lines here, but chaining them together. So, which is a nice thing you can do. So you say slider.new. Instead of a semicolon at the end here, we're going to delete that semicolon, and then just continue coding. So so here's our slider.new, and this line of code returns the instance of the slider, and then we immediately pass it the action method to define its action. And then we can also pass it another one, background color.rand. And yeah, so there we go. So we've sort of chained these 3 things together. We've defined its action, and we have given it a random background color. All right. Yeah, chat, you're being pretty quiet. Very quiet today. Just making sure everybody's still there and following along. Everything makes sense? If it doesn't, please let me know. So let's make another, okay, enough of this slider, right? Let's make another object here. How about a knob? Good so far. Cool. So we're gonna make a knob. It's gonna have the same parent. It's gonna be W, and we'll say we're gonna. Now this is where building GUIs can be a little tedious. So it's okay. This one's 50 pixels from the left, and it's 30 pixels wide, so that's 80 altogether. So we'll maybe give it another 20 pixels worth of space, 100 pixels over, 20 pixels down, so it's level, and we'll say 50, 50. So there we go. We can just run that. And if you don't like the position of the knob, if you've done this w.close business, you can just jump right in here and say, okay, let's just push it over a little bit more. Let's push it down. Didn't mean to push it down. We'll say shove it over a little bit farther. Okay, that's too much. So this is the workflow that I've gotten in the habit of doing. I'm not worrying about defining the knob's behaviors yet. I just want to see the window and see where the objects show up. Maybe we'll make this knob extra big old knob. So we got this knob and we got this slider. So I'm going to do something totally arbitrary here, and I want this knob to control the background color of the slider. So just like we did with the slider, we're going to say .action, and it's going to be a function. We're going to pass in an arbitrarily named argument, which represents the instance of the knob, and we're going to say, instead of post-lning its value, we can say knob.value. I guess we'll start by just post-lning its value. If I could type. So now we got this. So the knob has a value from 0 to 1. And what I would like to do is say SL dot background, set its background to be a color dot new, and we'll say knob dot value 0 0. So let's just digest this for a second. Whenever the knob's action is called, it posts its value, which let's comment that out. I don't want to see that anymore because we know what it is. It's between 0 to 1. And we are going to set the background of another GUI object equal to an instance of color whose red value is controlled by the knob. Ah, very nice. Okay. Not the world's most functional or utility-friendly GUI, but at least we're sort of getting there. In addition to all of the methods in the view, these are sort of methods that all views understand. It's always worth checking out the individual help file for the specific view class in question, because they're all slightly different, so they all have a few custom behaviors. For instance, the knob has a mode parameter. This is how you interact with it with the mouse, and the default is round, which means we move the mouse like in a circle around the knob, but we can set it to something like vert. So we say mode symbol vert, and so now we drag the mouse vertically to adjust the knob. If you've used a lot of GUIs in like DAW plugins or whatever, then you might find that you're subconsciously used to touching and moving knobs with the mouse in a very specific way. So you can do that with knob. I think knob also has color. Yeah, so instead of background, there's a color method which sort of overwrites that, and we provide an array of 4 color.news. Let's go ahead and do that just to see how that works. Color underscore, and then we say color.red, color.blue, color.yellow, color.green, just to be able to see these. Yeah, so red is the body of the knob, blue is the amount of the value sort of that gets filled in, yellow is the background of the sort of range, rotational range area, and then green is the little dial point. All right. Wow, that's a really hideous looking color scheme. Yikes. Okay. All right, so more GUI objects. Let's grab let's do a button. Buttons are really handy, yeah. So let's copy this business and clean this up a little bit. Okay, so we got this. This knob changes the color. I want to default the slider to black. See how it's got a random color, and then as soon as we touch the knob, it becomes black because we're interacting with the knob. So we'll say black. So now our slider is black. All right, let's make a button. Button.new, W, let's say rect 50, I don't know, 250. We got to keep in mind that we only have 400 pixels to work with. That's the size of our window. Let's say 220. Let's go 30. Let's see how that looks. All right, we got a button. There it is. It's a long button. Let's give it some stuff here. So, as always, button has just like any view object, an action. So we can just post its value, just giving us the number 0 right now. Buttons can have any number of states. So it can be a toggle button that has 2 states. It can be just a momentary button that only has 1 state, where you're sort of always in state 0, but you can sort of trigger its action by just pressing it once. It can have as many states as you want. It can sort of toggle through multiple states, more than 2. The way we configure the state, the number of states of our button is with the states method. And states is unique to the button class, I think. So it's supposed to be an array. So we set it equal to an array, and that array needs to contain additional sub-arrays based on how many states we want to have. So each state needs a string or a symbol, and then 2 colors, which is the color of the text and the color of the background. I might have those in the wrong order. Say color dot red, color dot black. Actually, let's go some more color methods here. We can do gray, and actually all of these specific colors you can add an alpha value, as well as let's see. So with like red, yeah, I do want full color. This is like saturation, so no saturation, half saturation, and then transparency. So we'll say gray. 0.5 is fine, and color dot green with like half saturation. And here we'll say state 1, color dot blue. Let's do cyan. 0.7, color dot gray 0.2. I don't know what this is going to look like. Let's find out. Okay, yeah, pretty hideous. We can barely see that it says state 0. So let's make this darker. Let's make this a little lighter. Okay, so it's a state 0. We click it, boom, goes over to state 1, which is cyan text and dark gray background. This is dark gray text and light green background. And now in the post window, we can see we're getting 0s and 1s, 0s and 1s. So we're toggling between states. And we could very easily add more arrays here to give it multiple states. Okay. Now what to do? Let's do we should bring some sound into the equation here. How about we'll say click to turn on, and we'll say click to turn off. So we want to say, let's just make a stupid sine wave. Book, right? Let's do that. And then maybe this slider will control the volume. How about that? I guess, if we're being very formal and robust, we'd probably build a synth def. So I think that seems like an appropriate thing to do. We can toss that right into our code if we want. So we'll say, I guess we should boot the server first. The server's already booted. Yeah, okay. Put this here for good measure. So we'll say synthdef new tone freak 440 amp 0.2 out 0, and we're going to need a gate for our envelope. So we're going to do ASR. Let's just say attack times 0, sustain level 1, release times 0. So just a hard rectangle shape. The gate is initially 0. and we'll say sig equals sign osc ar freak sig equals sig times env times amp stereo. So we're not hearing it in only one ear. And that ought to do it. Let's just run this, make sure that works. Looks good. Let's make a quick synth. Tone, gate 1. And we should say x.set gate 0. So, all right. So that works. So we just need to define a synth that has the attributes that it needs in order to work with this button. In fact, we're going to let's add this. Let's make a little separate bit of code here, because we can't. This is something that's come up on a few homeworks, which is people are trying to sort of add a new synth and instantiate a synth in one go, kind of one keystroke. You know, add the synth and then play the synth. And this doesn't always work. Like if I call this tone 2, if I try to run this specific block of code, I think we're going to get a synth not found. Yeah. And that's because it takes some non-zero amount of time to build the synth and push it over to the server. And so the language tries to call the synth before the synth is finished adding. So if we run this now, just this line here, it'll work just fine. It's just that it needed an extra microsecond or two to do that. So there are ways around this, but I think the easiest thing to do is to just put that in a separate chunk of code and run your synth, and then you can play your synth. So what we are going to do is create a synth called tone, and we're going to initially set its gate to 0 at the top of our GUI code, right? So if we show our node tree and we run this code, then we've got our GUI and we've got our synth on the server. And so we just need to change this button's action to basically set the gate of that synth, and that's pretty easy to do. I might do tone.free here, just so whenever we start this again, we're going to free that synth and then make a new one, so we don't have this buildup of synths. So we just got to say action, and now we need to actually we don't need to do any conditional logic. We could say like if here's the sort of unnecessarily complicated way to do it. If button.value equals 1, then we say tone.set gate 1, right? And otherwise, it's only going to have two. It's either 1 or 0, right? So we don't need to do any fancy stuff here. Otherwise, tone.set gate 0. So that is one way to do it, and that should work. So let's do it. Beautiful. And but we don't have to be this complicated. This is an option, but there's an even easier way to do it, because the values that gate needs and the values of the button view are the same. So we can just say tone.set gate button.value. Right? Just use the button value itself as a gate for the synth. And it's just convenient that it works out in this way this time. So this also works just fine. So we were going to do the amplitude of the synth with the slider. So we got to change the action of the slider. So we just want to say tone dot set view dot, sorry, no symbol there, view dot value. You know, I called this btn, I'm being kind of inconsistent here, so I should, just for simplicity's sake, let's keep our naming scheme consistent. So argsl. I don't think we need to post the value anymore. We know what it is. So we're going to say tone.set sl.value. Now, the value of the slider is between 0 and 1, and I definitely need to put amp there. It's not going to work otherwise. I need to say what parameter I want to set. So tone.set. So we're going to say set the amplitude to the value of the slider. This is going to be between 0 and 1, and you know, 1 is as loud as possible. So maybe we don't want to do that. So we might want to scale this or something, right? So we'll say when the slider is at its maximum value, the actual amplitude value is scaled by 0.2, you know, divided by 5. So that way, when it's at the top, it's not going to be crazy loud. Okay, so it's sort of working. One thing that we overlooked is that we're not using the default state of the slider in the synth, right? The synth is using its default amp argument, which is 0.2, but the slider's initial position is 0, and these are inconsistent with each other. So one thing we can do is we can just say, okay, just start, you know, initialize your value to be 1. And so now it starts at the top right here. And that's fine. The other thing we could do is we could keep it at 0 and move, or we could say, you know, amp 0.2 here. But I think it's a little bit cleaner. You know, I'm not an expert here, but let's put this at the bottom after we front the window. And we're going to say amp is sl.value divided by 0.2. Or sorry, not divided by 0.2, times 0.2. So it's actually going to query that slider. It doesn't have value right now because I think we closed the window. But it should talk to the slider. I think we might need to do this too. We'll initialize this value to 0. Let's see if this works. So when we make our synth, it's saying, hey, slider, what's your value? I'm going to take that times 0.2, and that's going to be my amplitude. And it looks like it works because the slider's value is initially 0. I wonder what happens if we get rid of this value. Oh, it still works. Okay. Now listen closely, because there is, I guess we could also, actually, before we move on, we can say button.value, I think. Right? It's going to say nil because it doesn't exist right now, but yeah. This is just, again, the similar sort of idea, grabbing the button state and using that as the initial gate. You know, there's no hard and fast rules here. You can kind of do it however you want. If you want to pull values from GUI in initializing your sounds, it's probably a good idea. I guess you don't absolutely have to. All right, so if we listen closely, there's this sort of clicking sound. Like it's not a smooth fade. Especially if we move the slider quickly. Because you know, there's a refresh rate on the screen, so it's only really updating the state of the slider X amount of times per second, which is a lot slower than the rate at which audio samples are generated. So there's this discontinuity. It's like sliders kind of jumping around, and so as a result, the amplitude of the tone is jumping around, and so we hear these amplitude discontinuities. So the way to do that is using a UGen called lag, not log, lag. Yeah, so lag is it is one way you can think of it as a low pass filter where it smooths out a signal by just sort of making it more sluggish. So we can say amp equals lag.kr amp, and then a lag time. So how many seconds do you want it to take for amp to get to where it's supposed to go? We can go with the default of 0.1 second. And so now amp is being run through this lag filter. So we'll rerun our synth-def, rerun this, and now it's a smoother sound. So if the lag time is too high, like if it's 3 seconds or something, then you'll get this kind of behavior. So it takes a long time to adjust. It's like way too sluggish. And if the lag time is too small, then you haven't gotten rid of your discontinuities and clickiness. So lag is really useful, especially when you're using GUI to control sound and you just sort of need the signal to respond in a way so that it's not constantly updating the discontinuous behavior of interacting with GUI. What else were we going to do? Let me just, I think that's probably pretty good. I want to use the rest of our time here to just show a few tricks that make working with GUI a little bit easier, and maybe just show off a few of the other objects. So let's just make a new window, and let's say view equals. So let's see. There's range slider. I'm not going to put an action here or anything. Whoa. I do not want to update my software right now. Thank you. Appreciate the timing. Okay. I messed something up. Yeah. It's got to be .new. So this is a range slider. You can set a range and then adjust that range as if it's a slider here. Let's see, what else haven't we looked at yet? Slider 2D is, well, it's exactly what it sounds like. It's a two-dimensional slider. So we've got this thing we can grab, and slider 2D does not respond to value. I think it instead responds to X and Y. So slider.x, slider.y, we'll put these in an array and post ln. So now in the post window we see the x value and the y value. Again, normalized, so 0 at the left, 1 at the right, 0 at the bottom, 1 at the right. So we've got an x and a y. This is good for doing sort of like morphing of sound, so you can have like, you know, a filter cutoff on the left and like a, you know, bit crusher or whatever on the top, so you can morph kind of fluidly. It's just nice. It's a nice tool. Another one we can check out is the multi-slider view. And let's just see what the default looks like. All right, so it's really boring. We need to do a little bit of prep on this one. Multi-slider view, is that what we're looking at here? Size, the amount of sliders. So we need to give it a size. Let's say 10. Okay, so now it's got 10 sliders. Let's give it more. It's probably too much. Say 20, and we'll just shrink its size like appropriately. I'll just shave away a little bit until, nope, that's the wrong dimension. So we'll say, I don't know, 280. And I've messed something up here. I deleted a parentheses. Okay. Oh, my typing skills today are abysmal. All right. If you're a pixel hunter like me and you demand perfection, that looks pretty good. So now we've got 20 sliders, and it's like a bank of sliders that you can click and drag across. This is good for I don't know, a bank of filters maybe, or maybe drawing an envelope shape, although there is a separate GUI for that. I think this is kind of like good for a sequencer. You know, if you have some p-bind or some pattern that's playing and you want to sort of pick amplitudes, you can sort of start high and go low, and it'll go something like that. Yeah, again, so you can check the help file for dealing with multi-slider view. It's a nice tool. There is number box. Let's make this 130. We don't need size. So number box, we can enter a number. And we can, of course, call value on it to get its value. just in some cases you might want to have a numerical representation of a slider so you can see the value of the slider as you move it, and you'd sort of lock these two GUIs together. All right, so a neat trick if you want to make a lot of GUI objects is use iteration. Let's say we want 10 sliders. We can say 10.do arg n. So n is going to be, when we do 10.do, it's the equivalent of doing the array of 10 integers starting with 0. So each item is going to be 0, 1, 2, 3, etc. So it might be nice to have that value handy. And we're going to say knob.new w rect. So we're going to say we'll start 10 down, 10 down. The width will always be the same. And we're going to need to manipulate this parameter according to n so that they all sort of get shifted over as they go. So we'll say n times, sorry, we're going to do, I think just n times, let's say times 15. No. All right. Yeah, I think n times 10, and then we'll also offset that value by 10. So we're going to take whatever n is, so 0 times 10 is 0 plus 10 gives us 10. 1 times 10 plus 10 gives us 20. So they're not going to move over enough. They're going to be overlapping, I think, because it's going to be 10, 20, 30, 40, but the sizes are pretty big. So let's just see what this is going to look like, Yeah, so they're all sort of clumped together. So we need to either make the knob smaller or make the offset bigger. Let's do a little bit of both. There we go. So the offset is they move by 30 pixels each time, and we're offsetting the whole thing by 10 pixels at the left. We can let's make our window larger, shall we? New bounds rect 300, 300, 1,000, and 500. So now we've got a larger space to work with. I'm going to push that over a little bit. Yeah. So let's make it 450, and let's make these 40 by 40. Yeah, so now we have some knobs. And another thing I didn't mention is I think a lot of these numerical GUI objects, there's a couple of keyboard shortcuts you can use. So let's see, R, when you select a knob, pressing R will randomize the value. C will center it, and then N and X. N and X set it to its lowest and highest position. So N is the bottom, X is the top. Why N and X, I kind of have no idea. You can also use the arrow keys to go up and down, just sort of tapping up or down or left and right. So we got a bank of knobs here. And the one thing that we could have done better here is use collect instead of do. Because when we say 10.do, we're not storing the resulting knobs anywhere. So we can say 10.collect, call this knobs. So now we have something called knobs, which is an array of knobs, which is really nice here because now we can say something like knobs at 2.visible false. And there it goes. There goes the knob at index 2. Or we can say knobs at 7 dot value 0.5. So through the use of code, we can manipulate a larger collection of knobs, and we can just, it's a little bit more intuitive. Rather than naming each one, knob 1, knob 2, knob 3, whatever, we can just index into an array of knobs and then talk to the knobs. And so if you want another GUI object to have this behavior, you just dump this code into the action function of that other GUI object. So views are, I mean, the whole world of GUI here, it's pretty homogeneous, which is nice because we've got all these different views, and we've got this view class, which defines a lot of common behavior. And as you can probably see, there's a sort of similarity to talking to these knobs and sort sort of making not just knobs, but any, knobs and sliders and buttons and everything, where you say, here's your action, here's your background color, things like that. Let me show. So it's a nice sort of design, and that once you get the feel of it, once you understand how to manipulate one GUI object, you basically understand how to manipulate all of them. All right, so let's do there's one more I was going to do. Oh yeah, so static text for labeling stuff. We'll say static text. I sort of did. I sort of did want to do some MIDI controllers. Let's make one of my knobs here control a GUI knob. Thank you for the reminder. Knob.new w rict 30 30 100 100. Okay, so there's our knob, and I'd like to be able to turn a knob here and make this knob move, right? So sort of making the GUI mirror the state of the controller. First thing we got to do, MIDI in dot connect all. So there is my nano control, and we'll just MIDI func dot trace true. So this knob here is controller number 23. Sending value 0 to 127 as expected. So 23. So here's what we got to do now. We'll make our window here. We'll just tuck that away. And I guess we can put this in the same clump. There's no harm. MIDI def.cc. This is going to be a control change MIDI def. We'll call it move knob. Arg. Value. We could pass in number and channel if we want. It doesn't hurt. And we are going to say kn.value is equal to oh, and this reminds me, before we go, I gotta also talk about value action. It's actually, I can't believe I overlooked this. It's really important. There's value and value action. And then this underscore means we're setting the value. So we're going to say val divided by 127, because these knobs have a normalized scale of 0 to 1, and so we're going to take the incoming value and just divide by 127. So the lowest value divided by 127 is 0. Highest value, 127, divided by 127 is 1. Right. And I think here we're going to get, oh, and then we want to say only listen to controller 23. Okay. So now if I move this knob, oh, okay, so it's not quite working. And I'm glad I showed this error earlier, but we're getting the same issue. You cannot use this Qt functionality in the current thread. Try scheduling on app clock instead. So there's some scheduling business that happens when a MIDI def or any kind of external data function is required to talk to GUI. But we don't have a fork or a play here. So how do we get this to happen on the app clock? The way we do it is we take the offending code, we put it in curly braces, and we say .defer. And defer is a method for functions that delays the evaluation by scheduling it. And I don't know what the default delta time is. I assume it's 0 or something really small. So basically, this code, instead of just running it in the main thread or on tempo clock or system clock or something, it makes a little sort of self-contained function and schedules it on app clock. So, excuse me, this should work. Yeah, so now I'm turning this knob, and it is working. So I want to give this knob an action so we can see the difference between value and value action. So we'll say .action, something very basic, knob.value.postln. Okay, so this knob, when its action is called, when we interact with it in a substantial way, it's going to post its value. So for example, now, if we move the knob, we get its value, which means it's evaluating its action function. Now, if we turn the knob on the MIDI controller, it's moving the knob, but the action is not being called. So that's what value does. Value, we can use value to say, give me your value. What is it? It's 0.89, blah, blah, blah. or we can also set its value with an underscore and then something in parentheses, which is what we're doing here. But this is the sort of very passive way of interacting with a GUI. We say, it's like you're being secretive. It's like, hey, I'm not touching you, but I want you to set your value to this new thing. And it says, okay, it's very hush hush. I'm not going to evaluate my action. No one's going to have to know. So that's what value does. It just updates the value, updates the appearance, but doesn't call the action. If we say value action, this is the alternative where we are not only setting the value, but also calling the GUI's action. So we see the knob move and its value gets updated, and we're also calling its action function. And if you have multiple GUI objects calling value action on each other, there's the potential for a feedback loop. So like if you have a knob and a slider updating each other, and if you move the knob and it calls value action on the slider, and the slider's action calls value action on the knob, then you will get the, if you're on macOS, you'll get the rainbow swirly of death. And it's like an infinite loop. It is an infinite loop. And so you need to be careful with that. So when you have two GUI objects and they're sort of talking to each other, you want to think about it in terms of a master-slave kind of thing. So like one of the GUI objects is responsible for calling value action on everything else, and all of the passive GUI objects will just call value on the, just to keep two things so that they have the same state. It's also good to just keep some spare variables around. So maybe both GUIs will update a variable. Or there's different ways to do it. You just got to sort of think about it pretty carefully and precisely about how you want to do it. But that's the this is how we do GUI and MIDI controllers. So we can make a bunch of knobs, and we can use iteration to be very, very slick about it. Yeah, so I think that's going to be it. There's things I didn't get to. There's a class called composite view. This is like a view within a view. It's basically just make one real quick. CV equals composite view. Let's see if I can do this real fast. And we're going to give it a background. Okay, I should have put that in a better spot. Let's push it all the way over. Okay, so a composite view is kind of like a view within a view. So we have our main window view, which is this, and we've put another composite view here. And so this is like a way of compartmentalizing and organizing your GUI objects. So you might have like a composite view for my knobs and a composite view for your sliders. And that way you can hide or make invisible the composite view, and everything on that view gets hidden. So for like to putting a knob on there, we'll say knob2 equals knob.new. We're going to put this on our composite view. So now we put a little knob here on that composite view. And so if we say CV visible false, then not only does the composite view disappear, but all of its children, everything that is planted on that view and everything on those views, it's sort of everything from that point onward gets made invisible. So it's instead of having to deal with lots of individual GUI objects, if they all belong in a certain category or family, make a composite view, put all your objects on there, and then you can deal with them. You can also say cv.children, and that gives you an array of all of its child views, which in this case is just an array of one knob. Okay, I don't want to go on too much longer, so that's going to be it for GUI. Hopefully this gives you a basic understanding. You can sort of start messing around, building your own windows and widgets and whatnot. So I'll post this video on YouTube as soon as possible and get this code up as well. And everyone taking the class, I'll see you on Thursday for an in-class and take-home assignment. Any last-minute questions you want to throw at me, please feel free. I'll stick around for a minute or two if necessary. But otherwise, thanks for watching. Thanks, Cody. No problem. Sure thing, Justin. Thanks, Jumbo. No problem, B. Hinks. All right. thanks everybody for watching. I'm going to call it and see you on Thursday, and also see you a week from today for the next stream. So see you later. Thanks for watching.